Welcome to a to-doodle about why division works. This one is more relaxing than the last one because you're mostly just going to watch me dance around on the stage. You get a break. So I want to start with the simplest kind of model of division, dealing out playing cards. And everyone has dealt out cards before pretty much. And let's think of how that works. So right now I have one card. So I'm going to make some copies of it. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So imagine I have all of these playing cards in a pile. I'm holding them in my hand. And I have 4 people sitting at a table. So here's my table. And we can even give it some color. And I have people at this table. Pardon my artwork. Now you know why I do math and not art. And I want to deal out my cards to these people. So here we go, 12 divided by 4. You get one, you get one, you get one, you get one. We've gone around the table once. Everyone gets a second card. Everyone gets a third card. And we're out of cards. So when I write this out, 12 divided by 4, what's the answer, by the way? Yes, you're holding up 3 fingers. So what is the 12 in this picture?
The cards.
Yeah, the total cards I had. And what do I have 4 of? It's how many piles I made.
People.
They happen to be people, but I'm going to use the word piles because maybe I was doing
Piles.
something else, right? And then what's the 3? What's my answer?
The number of cards were in each pile.
Yeah, the size of my piles. You're saying it more carefully, but I'm going to use fewer words to fit them on the screen. Everyone okay with that?
Mm-hmm.
Okay. Now let's do this with a big problem. So a problem we did the other day was 972 divided by 4. So I have a card. I'm going to put it over here for now. Let's first do the long division. So how many times does 4 go into 972? Ready to start? So I am some sort of casino dealer, but I have a superpower. I can reach into my stack of cards and pull up 100 at a time and always be accurate at that. Or I could pull up 10 at a time. So I have my giant pile of cards. Let's just imagine that this is 972 cards. I'm not going to actually try and make that. And I'm going to reach into that pile and grab 100. Can I do that again? Sure, I'll do that again. So there's another 100. And I can keep doing that. If I go around the table to the 4 people, if I give each of those people 100 cards, then that would be 400 cards that are not in my hand anymore. They are now around the table. If I went around twice and gave 100 twice to everybody, that would be 800 cards that are now not in my hand. They're around the table. Make sense so far? At that point, I'm down to 172 cards in my hand. So this is now a pile of 172. And I can't go around again. If I use up 400 cards, I'm going to run out on the second person at the table. So I'm going to stop using my superpower of moving 100 cards at a time, because I'm done with that. That's as useful as that has been. Now I'll switch to my other superpower. I'll go around 10 cards at a time. So if I give 10 cards to everybody, that would use up 40 cards, because each person would get 10 cards. And 4 10s is 40. If I had 172, can I go around a second time with 10 and 10 and 10 and 10?
No,
No, I can do that. If I had
Oh.
172, I've used up 40,
no, never mind.
but
never mind.
I still have dump loads of cards in my hand.
Never
So
mind.
let's do another 10. So that now brings this up to 80. Can I go around again with 10 and 10 and 10 and 10?
Mm-hmm.
Sure. So that now brings this up to 120. Can I go around a fourth time with 10 and 10 and 10 and 10? I can, so that brings it up to 160. And if I try again, the first person is going to get 10 cards, but then I'm going to run out. So I have to stop. Now the fact that I have the superpower doesn't help me anymore. I'm just a normal mere mortal. I have 12 cards in my hand. I'm going to deal them out one at a time to 4 different people. So if I go around once, that's 4 cards. If I go around twice, that's 8 cards. If I go around a third time, then that's all 12. And my hand is empty. I have dealt out all my cards. That makes sense so far? We don't write it like that. Instead, we say for these 200s, we're just going to put a 2 in the hundreds place. Instead of these 4 10s, we're just going to put a 4 in the 10s place. And instead of these 3 1s, we're just going to put a 3 in the 1s place. But that's what these mean. This means there's some sort of magic casino dealer that is giving out 100 cards at a time from 972, and he or she can go around the table twice. And when that happens, 800 cards are now not in that dealer's hand anymore. And then the dealer says, enough of 100 at a time, kind of collect myself. I'm holding 172 cards. I'll switch to going around with a pile of 10 and 10 and 10. I'm dealing out 10 cards at a time. I get around the table 4 times. One circle of the table is 40 cards, so 4 circles is 160. That leaves me with 12 cards in my hand to deal out. I will deal them out one at a time. I get around the table 3 times, and that uses them all up. Any questions on that? Tangentially, let me stop the recording. Okay, tangentially, Richard Turner is an amazing person that almost has this superpower, or maybe he even does. He is a card mechanic, not a magician. He is blind and he can reach into a stack of cards and just pull up 10 of them. If you look on YouTube for Richard Turner, you can be amazed at his card tricks. Okay. We got stumped the other day, since we're on a roll. Let's see if we can unstump ourselves. If we were to take a brownie, we had 6 pounds of brownie, and we cut it into half-pound pieces. How many pieces do we have? Can we model 6 divided by a half using cards? I have 6 cards. I'm going to start dealing them out. I'm not sure what to do. I can't give them to half a person. Right? The way we were doing things, then this number is how many piles we make. And I can't make half a pile. That doesn't make any sense. So we need a different model. We can't just deal out cards for this kind of problem. So I want to do a different thing. I'm going to make piles of a fixed size. So let's make a new page. But for now, change this to just be doing the problem we did the first time. So I have 12 cards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You with me so far? And I'm going to make piles of size 4. I no longer have any friends for me. Ooh. So here we go. Here's one pile of size 4. Great. Here's another pile of size 4. Great. And then here's another pile of size 4. Great. And now I've run out of cards in my hand, so I stop. So I again have 12 divided by 4 equals 3. But I've changed the meaning. This is still my total cards. That didn't change. But now this one is the size of piles. And this one is the number of piles. They're backwards from what they used to be. That's not how we're normally taught to think about division for some reason. Elementary school teachers like dealing out cards. They don't like making piles of a fixed size. But do you trust me that this method also works? So now I can do what I'm supposed to do. I want to do 6 divided by a half. So here we go. I'm going to have a playing card. And I'm going to make 6 of those cards. 1, 2, 3, 4, 5, 6. These aren't going to line up perfectly, just forgive me. Okay, everyone believe me that I have 6 playing cards, even if they are suspiciously cracked. Okay, now I'm going to make them piles of a half. Now I have piles of a half. How many piles of a half do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And just like we did in the previous doodle, if you're dividing by a fraction, you're shattering things, you're getting a bigger number than you started with. But I don't need a calculator to do 6 divided by a half. I just make piles of size 1/2, and I can see there's going to be twice as many of them. You may have been taught rules like dividing by 1 doesn't change a number. You can think about that both ways. If I wanted to do 12 divided by 1, that would just be saying, I only have one person at the table. Let's give that person all my cards. Not very exciting. Or to make piles of fixed size, I have 12 cards. I'm going to make a pile of size 1. I'm just setting my cards down one at a time, and I get to 12 piles because I just put them down one at a time. If I want to think about dividing by 0, whoops, typo, then dealing out cards doesn't help. Just like it didn't help with fractions, then I'm not sure how to take a bunch of cards and divide them up among 0 people. But I can make piles of size 0. That just means I don't take any out of my hand, right? Here's all my cards. Let's make a pile of 0. I still have all of them. Let's make another pile of size 0. I still have all of them. I can keep making piles of 0 all day. So that's why it behaves like infinity, because you never take any out of your hand. These we could do now, or we could have you try them over the weekend because it's a Thursday. Talk about them when I see you again on Tuesday. All of these are ones you can do. You can do them like long division. You can do them thinking in your head. You could take 36 cards or Cheerios or something and actually make piles of 4 or deal them out to people. So these are all things we can do. You want to do them now, or let your brain have some time with them first?
We can do them now.
Do them now. Okay. So 378 divided by 2. How would you do that?
That one's like the 972, huh? Kind of.
Yeah, well, that's long, looks like long division to me if I wasn't allowed to use a calculator. I'll start 100 at a time. Can I give 100 to 2 people if I had 378?
No.
I can. I could do that once. Then I have 200 less things. I'm down to 178. And I can't give everybody 100 again. Somebody would get the 100, but the other person would get shortchanged. So now I'll move on to tens. If I give 2 people 10, that's 20. If I do it again, that's 40. How many times can I give 10 to both people?
Just 3?
3. That
Oh,
would 2
yeah.
times 3 is 6. That's 60. I can get bigger than that.
Four?
Give out
Oh.
give out 10 people, 10 cards to 2 people. So 20
Two
cards
in the-
4 times. That would be 20 times 4 would be 80. I can fit more than that.
So 6?
Okay, so let's try. 6 times 2 is 12 with a 0 on it. I'm going to fit more than that. I can fit another 20 on.
So 20 into, okay, will you say that again? 2 into 20 into 78?
20 into 178.
20 into, okay. That'll be 7? 8.
7, actually can do it 8 times. 2 times 8
8,
is
yeah.
16, and that's still less. Now, an important
Okay.
thing is I'm, for the moment, writing this like long division. but we're going to do it again in just a moment with the line method. And then all of your other guesses would be great. They are not a problem with that other method. Now I'm doing one at a time. If I give out 2 and then 2 and then 2 and then 2, how many times can I do that to get to 18?
9.
9. Everyone with me so far? Okay,
Yeah.
so let's do 378 goes into 2, but let's just focus on that. I think I want more space. One moment. Okay, so I draw my line. And I start by saying, how many hundreds can I do? And just one. 100 times 2 is 200. And that gave us the 178. And now we started guessing. How many tens? How many? What if we did 4 tens? If we did 40? That would be 2 40s is 80. And then I can just subtract and keep going. Now I am at 98. 8 minus 0 is 8. Carry, we get 17 minus 8 is 9. So I can still fit in another 80. Now I can't fit another 10, right? If I put a 10 here, 2 times 10 is 20. That's going to be too big. So I'll do the 2 times 9 is 18 and finish off that way. So this was the way of writing it, that if I don't have my times tables perfect, that's not a problem. I don't have to get that 8 in one shot to make it work. When I'm all done, there's one more step though. I have to add up all these numbers and I would get the same 189 that I got over here. Questions about that one? So if you like this method better, it's a little bit less stress, but it's also not what you were taught probably. So pros and cons. Okay, that was this one we've done. 8 divided by a quarter. So I'm taking 8 things. Let me focus just on that. There we go. Okay. So I have 8 things and I'm breaking them all into quarters. So here's my 8 things. 1, 2, 3, 4, 5, 6, 7, 8. And they break them all into quarters. And all those pieces shatter out onto the table. How many little pieces will I have? 1, 2, 3, 4. Looks like 31. I have 31, I'm sorry, 32. Did I just say 31? 32. So I have 32 different pieces if all of these were to shatter down onto the table. Have you ever heard the rule that to divide by a fraction, you flip it over and multiply? No, okay, that's a rule that people get taught. assuming you had heard that rule, can you see it happening? That dividing by 1/4 is the same as a times 4. Because when I shatter something into fourths, that makes 4 different pieces. So dividing by 1/4 and times 4 are the same thing. It's just different ways to think about it. Am I making pieces that are a quarter of the whole, a quarter of a brownie, something like that? Or am I making 4 parts out of each thing I had? Okay, 36 divided by 4. How would I do that?
9 times 4.
Yeah. If I didn't just know it was 9, how could I do that? I could do long division.
Mm-hmm.
A lot of people, for numbers small like this, would just start counting their multiples. So how many times do you have to have 4 to go into to make 36? 4, 8, 12, 16, 20, 24, 28, 32. Ah, here I am, 36. So how many was that? That's times 1, times 2, times 3, times 4, times 5, times 6, 7, 8, times 9. That's what I wanted. So if I don't know my multiplication tables, I can just keep adding, make my list, and then count where on the list it is. It's the 9th thing on my list. But good job just knowing it's 9. Okay, now where are we? This one looks immensely tricky, but it's really not. If I have half of something, so let's say that the top half is Josie's. Oops, make that look like a. So here's Josie's half, and here is April's half. And we take Josie's half, and we divide it by 2. So this piece is the one we're talking about. How much of the whole thing is that?
1/4.
A fourth. Right? Lots of people would be amazed that you could do this problem without having to write out any fractions. Just draw the picture and you can say, ah, she has a quarter of the whole thing. She has a fourth of the whole thing. Okay, 225 divided by 5. If I just count by 5s, that's going to take a really long time. So that's not the right strategy for this one.
You could do the card method, like the way we, or what was it? Like how we did the 972.
So do you like the line or do you like the long division? Which should we do next?
We could try the line.
Try the line. Okay. So we have 5 going into 225. So I'll draw my line. Can I put 100 at a time? Can I deal out 100 cards to 5 people? That would take at least 500 cards, and I don't have that many.
Mm-hmm.
So no, that's not the right way to start. Can I deal out 10 at a time to people? Sure, that would only take 50 cards, and I have a lot more than 50. Do you want to start with going around the circle just once with 10s, or should we make this a 20 or a 30 or a 40 or a 50 or something like that?
A 20?
20, okay. Again, if we pick wrong, that's not a problem. We just erase it and keep going. So 5 times 20 is 100. 5 times 2 is 10 with one extra 0 floating around. So now I'm at 125. I can do that again. So I take my 5 people and I give them each another 20 cards. That uses up another 100 from my hand. And I'm down to 25 cards that I'm holding. Can I go around again with a 10? No, that would use up 50, and I don't have 50 cards left. So now I'm down to 1 at a time. And you're holding your hand up to say 5. Yes, 5 times 5 is 25. I'm out of cards. I'm done dealing. Then I add these up, and I get 45 as my answer. If you like long division, we can do it that way also. If you liked the other method we just did, feel free to tune out and think about something else for a moment. Does 5 go into 2? No. Does 5 go into 22? Yes, 5 times 4 is 20. Carry down the 2, the 5. Does 5 go into 25? Yes. And I'm done, and my answer is the 45. So long division, again, takes up less room on the paper. And if you are good at it, it is faster. But
That's the one I'm used to.
yeah, you have to know your times tables though, because if you tried a 2 there, it doesn't work. Whereas with this method, I can whittle things away a little at a time. Okay, 1/2 divided by a quarter. This is different. If I am going to make the same picture up above, so we have whatever this is, piece of brownie or something. We have Josie's half. Oops. And we have April's half. Now I'm saying let's make piles of size 1/4. So just for Josie's half, how many piles of size 1/4 can she make?
Okay.
Are we splitting the 2 piles into like 4s?
Yes, you're taking your half of a brownie and saying, how many quarter brownies do you have? Your kids say, I each want a quarter brownie. How many can you give a quarter
Would
brownie?
be 8, right, in total?
No, just 2.
Oh, 2. Okay. I thought we were like cutting
Someone else will-
them into like 4s each.
someone else will- okay.
So these are different. This is, I have a half. I cut it into 2 pieces. How big was my piece? It's a quarter. I divide it into 2 pieces. Whereas this one is, I have my half. I'm making piles of size 1/4. how many quarters of the brownie do I have? I have 2 before I run out. Okay. As your thinking thing for over the weekend, the kindergartners, Kira and Keisha, are best friends. They like to share everything equally. They can share candy pieces by moving them one at a time into piles. So 1 for Kira, 1 for Keisha, 1 for Kira, 1 for Keisha, right? They don't even have to know how to count or divide to just split that 50-50. Make sense so far?
Mhm.
Today, their kindergarten class learned about shapes. A square is like a sandwich, a rectangle is like a candy bar, a circle is like a pizza, and a triangle is sort of like a slice of pizza. And since they like sharing everything equally, they want to know how many ways they can share each of those 4 shapes. So their first thing they thought of is they could cut the square sandwich in half up and down, and the 2 sides are the same. But we can think of other ways too. I could take my square sandwich and cut it diagonally. And then those 2 things are the same also. So think of all the different ways. How many ways are there to share each of these shapes between the 2 best friends? And then you can extend the challenge. What if there were 3 kids or 4 kids? And lastly, is this division? It doesn't have any numbers. There's no numbers anywhere on this page. Does it still count as division, even if there's no numbers, because we're making piles of the same size? As a tangent,
I would say yes.
Yeah.
I think most people would say yes. Yes, that seems right. As a tangential family story, when my sister was 2, my brother, who was older than her, would torture her. She liked having her square sandwiches cut diagonally. For some reason, that seemed fancy to her. So he would reach across the table and spin the sandwich. And she would start out happy because my mom had cut it diagonally. But then when it had spun a little bit, the cut would look up and down, and then she'd be sad. And then he'd keep spinning it and she'd be happy. Now it's diagonal the other way. And then he'd keep spinning it and it would be flat across the middle and she'd be sad. And it was just very funny to him how she would be happy and sad because she was still too young to understand that it was the same no matter what was happening.